There is a puzzle most people know. 3 pegs, a stack of disks. You move them one at a time, and you never put the larger disk on a smaller one. It has a name, it's the Tower of Hanoi, and it has one rule. A team at Tufts turned that puzzle into a robotic benchmark. Blocks instead of disks, platforms instead of pegs, same constraint. Then they compared 2 kinds of AI on it. One was a standard VLA, that is a robot model that sees, reads instructions, and turns them into actions. And the other was Neuro-Symbolic. That means it learned the messy movement part, but used explicit planning for the rule-based part. The Neuro-Symbolic system solved 95 puzzles out of every 100, while the best standard model solved a measly 34. And the energy number was off by 2 zeros. I checked twice. Not a typo. About 1/100th of the training energy. Far less energy during execution, better accuracy. If you're curious, the paper went up on arXiv in February, and Science Daily wrote it up earlier this month. For the last few years, the answer to almost every AI problem has sounded the same. More data, bigger model, more compute, more energy. The electricity curve around the infrastructure keeps bending upward. The default answer has been scale. This paper did the opposite move. The neural part wasn't asked to rediscover the whole puzzle from examples. That was the important move. What the team added wasn't more parameters, it was structure, written down, the kind the child learns when they pick up the puzzle. This block can go here. That one cannot go there. The sequence must preserve the rule. Researchers have been circling this idea for years. A useful AI system often needs 2 things: pattern matching, which neural networks do well, and structured reasoning, which pure neural systems often do badly. The Tufts paper shows the cost of ignoring that distinction. Of course, the cheap takeaway is neural networks are over. That's not what's happening. Both halves do work, the other half cannot. The neural part handles messy perception, while the symbolic part keeps the task consistent, inspectable, and cheap. This is the same shape as a point I named in Elastic Automators. The mistake of asking the system to be a mind. Treat it as automation with structure, and the engineering gets clearer and cheaper. The narrower claim is enough. When a task has rules, hiding them inside weights is wasteful. So the lesson isn't really about one robot moving blocks. It's about the 2 zeros. For a long time, the recipe was scale first, structure later. This finding flips that. The recipe is structure first, then scale. That's structure before scale. One of the 4 principles the work runs on at Hyundai. The paper just gave it a receipt. The 2 zeros are the receipt. Same puzzle, better answers. 1/100th of the training energy. The model didn't get bigger. It got more legible. The rule is the work.